today's tutorial, we're going to learn how to hide the fact that our foliage is made out of large planes instead of individual leaves. In order to reduce our polygon count, we've created our tree canopy out of large planes, and then we've created the texture for the planes with dozens of leaves. This gives us dozens of leaves on a single polygon, instead of using dozens or hundreds of polygons on each leaf. If we change our shader to remove the opacity mask, you can see that our tree geometry is made up of these large planes with lots of leaves mapped to each one. And this is great because it means we can make a tree with thousands of polygons instead of millions. But this technique does have some artifacts. Even if I plug back in our opacity mask, you can still see that we're using flat planes, especially when the planes are facing or not facing us when they're at glancing angles. And so a lot of the shader techniques that we use on foliage are to hide these planes and make it appear that we have a tree with millions of individual leaves instead of just hundreds of large flat planes. And so today we're going to focus on clipping out the planes when you see them at glancing angles. However, before we jump into that, there are two things that I want to fix in last week's shader. The first thing is, can you see how the tree has these branches that are just kind of sticking out in weird directions? That's because the UV coordinates in our shader are different than the way that the leaves were mapped originally on this geometry. And so what I'm going to do is just jump over here to our shader, and I'm going to bring in our texture coordinates, and what we need to do is invert the V coordinate. So I'm going to mask off my red and green channel and split them up. So I have my red channel here and I have my green channel here, and I'm going to invert the green. So I'm just going to add a 1 minus to invert my V coordinate, and then I'm going to bring those back together with an append vector node. And with these new UV coordinates, I'm going to plug those into my leaf wiggle mask, and also over here to my diffuse and my normal. And now you can see that I no longer have those weird branches sticking out at strange angles because I inverted the U coordinate and mapped the leaves correctly to the planes. The other thing that I want to do is, in last week's tutorial, we multiplied our opacity mask by a multiplier of 4. And the reason that we did that is because the branch parts of the opacity mask were fairly dim, so I wanted to boost those up. But I think the value of 4 was a little bit too high. So I'm just going to change that to a value of 1.5. And with those changes, we're ready to jump in. Now what we want to do is, if we take a look at our tree again, you can see that some of the leaves it's really obvious that they're on planes, especially when I'm looking at the planes when they're flat. I have a little plane here, down here, that I want to use to illustrate this. The leaves look pretty good when I'm looking straight onto the plane like this. But as soon as I turn to the side and I can see the plane like this, then it becomes really obvious that all of those planes live on one, or all of those leaves live on one single plane instead of being individual leaves. So I need to change my shader so that when I'm looking at the leaves like this, they show up, but when I'm looking at them at a glancing angle like this, they disappear. That will hide the fact that the leaves are on a flat plane. Alright, so in order to illustrate this principle a little bit better and keep it simple, I'm going to build a little test shader for this plane, and we're going to work on that together, and I'm going to make it fade out, and then we'll transfer that same principle over to our tree. So I'm just going to come over to our starter content, materials, and I'm going to make a new material. And I'm just going to name this plane fade out. And I'll select my plane and apply my material. And then let's open this material and make it fade out when we're looking at it on glancing angles. So the first thing that we need to do is change our blend mode from opaque to masked, and that will expose our opacity mask pin so that we can make our material fade out. Okay, so I'm going to take the camera vector and I'm going to do a dot product between my camera vector and my normal. So here's my dot product node, and I'm going to bring in my vertex normal. And so what this is going to give me is when the camera vector and the normal are parallel, I'll get a value of white, or a value of 1. And when they're perpendicular, I'll get a value of 0. Now, when they're opposite, I'll get a value of -1, but I don't really care about that for now. So I'm just going to wire this directly into our color, just so you can see what it looks like. And let's switch back to look at our plane. And so you can see that when I'm looking straight at the plane here, it's white, but then as I rotate around to the side, you can see the plane, it begins to get dark. And so this is what our dot product is doing. It's measuring the angle between our surface normal and our camera vector. And when those two are perpendicular, I get a value of 0. And when they're parallel, I get a value of white. So this is the basis for what we want to do with our plane. So I said I didn't care about the value going negative, but I actually do, because I'm going to change this so that my plane is double-sided. And now I'll show you that when we come around here to the back side of the plane, it's completely black. And we don't want that. We want it to be black when we're looking at it at a glancing angle. But on either side, no matter which side we're looking at, we want it to be white when we're looking at it straight on. And so in order to do that, I need to add an absolute value node. And so this is going to take any values that are negative and automatically make them positive. And so now if we switch over, you can see that we're going dark as we look at the side, and then as we come around to the other side, we go white again. And that's great. That's exactly what we're looking for. So now, if we take these values and instead of wiring them into color, if we wire them into our opacity mask, you can see that my plane is there when I'm looking at it straight on, but then as I come to the side, can you see how it's clipping out? That's because my opacity is turning black as I get to the side. And this is the technique that we want to use. Now, this plane is clipping out a little bit early. I think maybe I only want to lose it when I'm actually looking at it at a glancing angle instead of this early. So I need to adjust my value just a little bit. What I'm going to do now is invert my value. I'm going to go 1 minus. And then I'm going to multiply the value by itself. This is kind of like raising it to a power of 2. If I multiply the value by itself. And then I'm going to invert it again. So I'll add another 1 minus to bring it back to the white to black range that it was before, and then wire that in. And what this is going to do is change where the plane actually fades out. So I'll be able to rotate around a little bit farther now before the plane is gone. Okay, so this is the technique that we want to use and apply to our tree leaves. And so I can just take this portion of the shader and copy it, and I'm going to paste it into our tree leaf shader here. And let's go ahead and plug this. Instead of plugging this into the opacity, I'm just going to turn off opacity for now. And let's plug this into the color so that we can take a look at the results that we're getting. And if we zoom out here and come on up and take a look at our tree, what we want to see is we want to see the tree leaves fading out when we look at them at glancing angles, or we want the planes to be white when we're looking straight at them, and then we want them to be black when we're looking away from them. And I'm seeing some kind of weird results. Like, can you see this black line right here? I don't think this is right. So it should be white when we're looking at it straight on, and then it should fade to black when we're looking at it like this. But instead, we're getting these weird lines. And the reason that we're getting these results is that the surface normals of these planes are not pointing in the direction that the planes are actually facing. And in order to show you that, I'm going to select the tree, and I'm just going to bring up the tree model itself, and we're going to turn on the normals. Now, I hope this is obvious. It's actually pretty subtle. But if we come over here to the ends of a branch, and we look at the normals, I want to show you that the normals are actually not pointing in the direction of the planes. They're pointed outward. Can you see these little green lines here? They're actually pointed out and away from the tree. If we look here at the top, these are pointed up, and these normals here are pointed out to the left. And so what's happened here is the normals of our vegetation have been adjusted. So instead of pointing along in the direction of the plane, they're pointed out away from the center of the tree. This is something that we'll talk a little bit about in next week's tutorial, but in order to actually get good results, we need to do something a little bit tricky to overcome the fact that our surface normals are no longer pointed in the direction that we need them to be. So what we're looking at here are the vertex normals. And like I said before, these vertex normals have been tweaked and adjusted so that the lighting will look correct on this tree. What we actually want to fade out the faces is the face normal. And so what I'm going to show you now is how to compute the face normal of a polygon when you have a vertex normal that doesn't actually represent the direction that the face is facing. So just to kind of explain what I'm going to do beforehand, there are two nodes in Unreal. One is called DDX and the other one is called DDY. And what these give you is the slope of the surface. So DDX will give you the slope of a face going in the X direction relative to the screen. And DDY will give you the slope of a face in the Y direction relative to the screen. And so if we have the X slope and the Y slope, and then we do a cross product between those two, what we'll end up with is the face normal. So we have a vector going in this direction and a vector going in this direction, and we do a cross product between those two and we get the face normal that we're looking for. So let's go ahead and implement that now. We need to do this instead of our vertex normal here. So the first thing that I'm going to do is add our absolute world space position, and then I'm going to add our DDY and our DDX. So this is going to give us the slope in the Y direction of the screen, and this is going to give us the slope in the X direction of the screen. And now, like I said, we need to take the cross product of these two, and this is going to give us the face normal of the polygons. And so we're going to normalize this, and I can use this as my normal instead of my vertex normal. Just to illustrate this, I want to show you what this looks like. So if I take my vertex normal world space and plug it into my color, you can see that these normals are not, they're not flat. Can you see how there's this gradient here? That's because the normals have been bent. But if I take my face normals that I just computed and plug them into color, you can see that I'm getting a single normal for each individual face and the direction that it's facing. So this is a fantastic trick. When we've tweaked the normals so the lighting on the foliage looks correct, we can still derive the normals of the faces using this DDX and DDY trick. So I'm just going to plug this into our dot product here instead of the vertex normal. And then I'm going to take this bit of shader code that we've created and I'm going to multiply it by our opacity mask. So our opacity mask is currently at 1.5, and so I need to saturate the result of that. And then I'm going to multiply that by the mask that we've created based on our face normal. And then we'll wire the result of that into our opacity mask slot here on our root. And then one last thing I'm going to do is I'm just going to take our color and plug it back into our base color node. All right, and now you can see that we're getting our final results. Now what I want to do is rotate the tree around a little bit, and I want you to watch and see that the planes fade out as we get to glancing angles. So as I look at the planes at glancing angles, they disappear. So instead of showing off the fact that all of the leaves are mapped to a single plane, they just go away. And that's basically hiding the fact that the planes are flat and that the leaves are all on a single plane. So I really like this trick. It's something that we use to make the leaves just look better and to kind of try to hide this trickery that we're using and make the leaves still feel like they're part of a volume, even though they're each mapped on individual planes. Alright, before I sign out today, there's one more thing I want to address. Last week somebody asked in the comments if I could go over vegetation or foliage shaders for mobile. And I just have a couple of comments that I wanted to make on that. First of all, I haven't created any mobile games myself, so I'm not really qualified to do that. But what I would say on that topic is pretty much all of the things that we're doing here are more for high-end platforms. And if I were doing this for mobile, I'd probably make a shader that was just the single leaf texture and maybe a normal map, maybe not. But just keep this as simple as possible. So basically, like, I would get rid of the leaf wiggle, I would get rid of this plain fade out thing that I'm doing here, and just use like a single texture mapped to the base color and the opacity. Pretty much all the fancy stuff we're doing here is try to make our vegetation look as good as we can. And if your main concern is performance, you can get rid of all the fancy bells and whistles and just do something like as plain as possible. So that's my advice for mobile. Like I said, next week we're going to focus on this idea that I introduced today of the vertex normals being warped and not actually representing the face normals at all, but that the vertex normals are warped. We'll talk about that more in next week's tutorial. I hope you enjoyed the tutorial today, and we'll see you next week.